In chemistry, a reaction only happens when the conditions are right. It's no different in real estate. Welcome to the Alkaline Reaction, a podcast from Alkaline Advisors, where we break down the deals, partners, and capital structures that turn opportunities into outcomes. I'm Spencer Carenti, and today's reaction, engineers. If architects translate a development vision into a spatial design, engineers ensure that design can actually function in the real world. They determine how buildings stand structurally, how air circulates through them, how electricity flows, how water moves through plumbing systems, and how sites connect to infrastructure like roads and utilities. In many ways, engineers form the technical backbone of the development process. Their work determines whether a building can be constructed safely, efficiently, and within budget. And because engineering decisions influence both construction costs and long-term operating performance, they play a critical role in the economics of real estate development. So today, we're going to walk through how engineers fit into the development process. We'll start by discussing how engineers collaborate with architects and developers early in the design phase. Then we'll explore site engineering and feasibility, where engineers analyze whether land can actually support a proposed development. After that, we'll look at the major engineering disciplines involved in building design, including structural, mechanical, electrical, plumbing, and civil engineering. We'll also discuss how engineers coordinate complex building systems during design development and permitting. And finally, we'll look at their role during construction, where they help ensure that the building performs exactly as intended. If you step back and think about buildings as complex systems, engineers are the professionals responsible for making those systems work. At the beginning of most development projects, engineers are brought in shortly after the architect begins developing early design concepts. While architects focus on spatial layout, form, and user experience, engineers begin evaluating the technical feasibility of the building. Their job is to answer a series of fundamental questions. Can the structure safely support the weight of the building? How will heating and cooling systems operate within the building? How will electricity be distributed throughout the property? Where will water enter and exit the building? And how will the building connect to surrounding infrastructure? The answers to these questions shape many aspects of the building's design and cost. One of the earliest areas where engineers contribute is site feasibility. Before a building can even be designed, developers need to understand whether the land itself can support the project. This is where civil engineers and geotechnical engineers play a critical role. They analyze the physical characteristics of the site, including topography, soil conditions, groundwater levels, and underground rock formations. These factors determine what type of foundation system will be required to support the building. For example, if soil conditions are unstable, engineers may recommend deep foundation systems, such as piles driven into bedrock. If groundwater levels are high, specialized waterproofing and drainage systems may be required. These engineering requirements can significantly affect construction costs and influence the overall feasibility of the project. Engineers also analyze how water moves across the site. Stormwater management has become increasingly important in modern development because cities require projects to control runoff in order to prevent flooding and reduce pressure on municipal sewer systems. Engineers design drainage systems, retention basins, and underground storage structures that manage rainfall and protect both the property and surrounding infrastructure. Another important component of site engineering involves infrastructure connections. Buildings must connect to municipal systems for electricity, water, sewer service, telecommunications, and sometimes natural gas. Engineers evaluate whether the surrounding infrastructure has sufficient capacity to support the development. If upgrades are required, those costs must be incorporated into the project's financial model. Once site feasibility is confirmed, engineers become deeply involved in designing the systems that allow the building itself to function. Several engineering disciplines typically participate in this process. Structural engineers are responsible for designing the framework that supports the building. They determine the size and placement of columns, beams, and foundation systems. They analyze how loads travel through the structure and ensure that the building can withstand forces such as gravity, wind, and in some regions, seismic activity. Structural design must balance safety, efficiency, and cost. For example, A structural system that uses larger spans may create more flexible interior layouts, but may also increase construction costs. Mechanical engineers design the systems that control a building's internal environment. This includes heating, ventilation, and air conditioning systems, often referred to as HVAC. Mechanical engineers determine how air flows through the building, where equipment is located, and how systems are sized to maintain comfortable indoor conditions. These systems are particularly important because they often represent a large portion of construction cost and play a major role in long-term energy consumption. Electrical engineers design the systems that distribute power throughout the building. Their work includes electrical panels, lighting systems, backup power systems, fire alarm networks, and increasingly complex technology infrastructure. Modern buildings rely heavily on electrical systems to support elevators, security systems, telecommunications networks, and smart building technologies. Plumbing engineers design the water supply and drainage systems within the building. They determine how water enters the property, how it is distributed to individual units or tenant spaces, and how wastewater exits the building. They also design domestic hot water systems and fire sprinkler systems, both of which are essential for building safety. Civil engineers focus on the site outside the building. They design grading plans, roadways, sidewalks, parking areas, and utility connections. Their work ensures that the building integrates properly with the surrounding urban infrastructure. Once these systems are designed, engineers work closely with architects to coordinate them within the building. This coordination process is complex. Mechanical ductwork must fit within ceiling spaces. Structural systems must align with floor layouts. Plumbing systems must stack vertically through the building. Electrical systems must reach every unit and tenant space. Engineers use detailed drawings and modeling tools to integrate these systems efficiently. This phase of the project is often referred to as design development. During this stage, the design team refines the building systems and produces technical drawings that will ultimately be used for permitting and construction. Local building departments review engineering drawings to confirm that the project complies with structural, mechanical, electrical, and life safety codes. These regulations exist to ensure that buildings are safe for occupants and resilient to environmental forces. Without engineering approval, construction cannot proceed. Even after construction begins, engineers remain involved in the project. During construction, contractors may submit shop drawings that detail how specific components of the building will be fabricated and installed. Engineers review these drawings to confirm that they meet design requirements. They also respond to technical questions that arise during construction and sometimes visit the site to inspect critical elements of the structure or building systems. Construction projects frequently encounter unexpected conditions. For example, excavation may reveal soil conditions that differ from earlier surveys, or adjustments may be required to accommodate field conditions. Engineers work with contractors and architects to develop solutions that maintain the safety and performance of the building while keeping the project on schedule. From an investment perspective, engineering decisions influence several major drivers of real estate performance. First is construction cost. Structural systems, mechanical equipment, and infrastructure requirements all influence the development budget. Second is operating efficiency. Mechanical and electrical systems determine energy consumption, maintenance requirements, and overall operating expenses. Third is building resilience. Engineering design ensures that buildings can withstand environmental stresses such as wind, heavy loads, and temperature fluctuations. And finally, engineering decisions affect long-term asset performance. Well-engineered buildings tend to operate more efficiently, experience fewer system failures, and maintain their value over time. So, while engineering work often remains invisible to the people who occupy a building, it is essential to both the functionality and the financial performance of real estate assets. If we step back and look at the development process as a whole, engineers play a critical role in translating architectural design into systems that actually work. They ensure buildings are safe, efficient, and connected to the infrastructure that supports modern cities. And because their decisions influence construction costs, operating performance, and long-term durability, Engineering plays a central role in determining whether a development project ultimately succeeds. That's today's reaction. If you found this episode helpful, please subscribe and join us next time as we continue breaking down the commercial real estate industry. I'm Spencer Carenti, and thank you for your time.